start off our show, let's go to Jesus.
Okay, I misspelled battery, but I don't know why. Okay, you use this battery, you plug in a positive and negative. Positive, negative. Okay, these are lines that metal, whatever. You know what it is. Okay, they go and they go and they go and they hit a light bulb. I don't know how to draw it, but do my best. Look! Okay, once they hit this, okay, it's a current going to the light bulb. Not lit up yet, but then you get that, and then it goes, and then there you go. You got your circuit. Your simple circuit. And if you want to be complex about this, you can add a switch. On, off. Switch. You can turn it off and on. Like a boss.
And now, let's move on to Jimmy as he answers some questions.
So, one of the questions was, which direction does electrons flow in a circuit? Electrons flow from the negative terminal of the voltage source to the positive terminal of the voltage source.
To move on in our show, let's go to Armando.
Okay, what is resistance? What resistance is the measurement of how hard it is to push an electric circuit through a circuit. And how the way you figure out resistance is voltage over the current of electricity.
And now, let's go back to Jimmy as he has more questions to answer.
Another question we had was, what was voltage and how is it measured? Well, voltage is an electromotive force or potential difference expressed in volts measures the difference in electric potential energy. Voltage is the difference between 2 points, and it also has two common voltage measurements, which are direct current (DCV) and alternating current, which is ACV.
And now, let's go back to Armando as he has more information to share with us.
What is current? Current is the flow of electric charge. How do we measure? We measure with an ammeter and in units called amperes or amps. That is a little device we use in our circuit experiment that looks like a little square with a little circle and those two cables. Alright.
And now, let's go to Juan.
This is a simple circuit, which is from battery to light to battery. Basically, rotation. Parallel circuits, battery to light to light to light, which goes back to the battery.
And now, let's go to Giovanna as she has some information for us.
Really? See, how was your day today, Juan?
It was spectacular.
Amazing. And you, Jesus, how was your day?
It sucked.
I don't care really. Okay, guys. Well, today we'll be talking about equivalent resistance. Do y'all know what that is without looking for it?
No.
You want to take
No
a
sé,
guess?
señorita, no comprendo.
You want to take a guess?
I don't
It's
know what
equivalent to the resistance
Is it
of...
potato sack?
You can make French fries.
For real?
You put the circuit in her. In it. Okay, let's go. Well, equivalent resistance is a resistance that represents the total ohmic values of a circuit component or group of circuit components. Did you get that?
Yeah, we got it.
Can y'all like dummy that down for the people that don't know it?
I don't know it.
Come on, guys. Take a try. No? No?
Cricket
Yes?
sounds.
Okay, we're done.
Now, let's move on to Andrea. Okay, so we're going to talk about series currents and parallel currents. Okay. In series, the current is the same throughout the entire circuit.
Mm-hmm.
The resistance is found by adding resistance values of individual resistors. The voltage is found by adding the voltage of each source. In parallel circuits, the current breaks up throughout the entire thing. The resistance is found by adding up reciprocals of resistant values and then taking the reciprocal of the total. The voltage is the same across each resistor.
Mm-hmm. Yay!
To finish off our show, let's go to Giovanna.
A capacitance is the ratio of the change in an electric charge in a system to the corresponding change in its electric potential. To find parallel, Q1 equals C1 times V, Q2 equals C2 times V, Q3 equals C3 times V, and V equals VAB. In a series, it's 1 over C EQ equal 1 over C1 plus 1 over C2 plus 1 over C3.
And thank you for watching. That was our show for today. Tune in next